everyone. So today we are working on Unit B, Matter and Chemical Changes, and the topic for today's lesson is factors affecting chemical changes. So apparently today we are in the lab. So before starting anything, what lab safety rules do you remember before starting any lab? Refresh my memory. What should I do now?
Put on safety goggles.
Yes, so I have to put on my safety goggles. What else do I have to do? What I'm wearing? I'm wearing a lab coat. It's essential to wear a lab coat while you're doing your experiment. And for this one, I'm bringing gloves. So I have to wear gloves in case of any chemicals that might spill on my hands, right? So make sure before starting any lab that you are taking safety precautions before doing so. So before starting my experiment and the purpose of doing my experiment for this unit is written here on the board. What is the objective for today's lab is to identify conditions that affects rate of reaction. So first of all, what is a chemical reaction? So yes, a chemical reaction when one substance changes to another substance with different identity. So if you're using your own language, you can easily define that when a substance changes to another one, it's totally new with totally new characteristics. Okay. How can you tell if a chemical reaction is taking place? Heat? Yes, if it's getting out heat, if taking in heat, if it is released any kind of gas, changing color. So all of these are signs for a chemical reaction. Okay, can you tell me why some reactions are happening very fast, like explosions, while other chemical reactions are occurring at a very slow rate, like iron rusting? Could you predict the reason for that?
Different reaction rates.
Yeah, because it depends on the rate of the reaction. What is a rate? What is the meaning of rate?
Speed.
It's related to the speed of reaction. Okay, so today I have a problem for you and I want you to solve it with me. So I have severe flu symptoms and I'm very sick. So I went to the pharmacy and I got Alka-Seltzer and they told me that this is a pain relief. However, I need to relieve that pain very fast because I have a lot of things to do and I have a lot of things to study. So can you help me taking this medication and having it or helping me to have a quick relief of pain? Any ideas? So if not, this is what we're going to explore today. So first of all, we will get 2 clean beakers and I will have my medication here. So what I'm going to do, I'm going to have a tablet. This is a whole tablet. I will put it in here. And another tablet, I crushed it using these instruments or these lab equipments. What are these? So what is the name of this lab equipment?
Mortar.
A mortar. And what is this? A pestle. So I got a tablet and I crushed it here. And this one, I have it as a whole tablet. So before starting, can anyone tell me what is the definition of a surface area? So if we are comparing these 2 tablets, the whole tablet and the crushed tablet, which one has a bigger surface area?
Crushed.
The crushed. Why do you think so?
Because it takes up more space.
Yes, so if we can visualize what is happening, a surface area is the total surface of the tablet, right? So the upper surface, the lower surface, and the circumference, right? When I start breaking the tablet, what am I doing now? creating new edges, right? So I will have more particles of the tablet being exposed to whatever reactant I will put it in, right? Okay, so first of all, I will get, what is this?
Graduated cylinder.
Yes, and I will have 75, or let's say, yeah, 75 milliliters of water in each beaker. While I'm doing so, is it important to have the same volume of water in the two beakers?
Yes,
Yes. Why do you think so?
so that they're in the same reaction conditions.
Yes, and what else? So what am I changing here in my reaction?
Surface area.
I'm changing the form of the tablet. So one is a whole tablet, another one is a crushed, right? So I'm changing now the form. So again, is it important to have the same amount or the same volume of water in each beaker? You said yes. Can you elaborate more on why?
Well, the surface area is the manipulated variable, and so all other variables need to be controlled.
Absolutely. So if I'm changing both the volume of water and the form of a tablet, when I have any differences in my observation, I cannot relate them to the form of a tablet, or is it because the volume of water, right? So when I'm doing any experiment, I have to have one thing change at a time. Okay, so now I need 2 volunteers with a stopwatch.
Yep.
Okay. So what I'm going to do now, I will place both tablets on top of water, and I will ask the 2 volunteers, once I put the 2 forms of tablet in water, to record the time till the reaction stop. Before doing that, I want to ask you a question. Which one do you predict will react faster with water, the whole or the crushed?
Crushed.
Can you explain why?
More surface area.
Because it has more surface area. So I told you to record till the reaction stop, right? Okay, and for those who are not recording, record your observation, right? So 1, 2, and 3. So you said the crushed one will react faster with water because it has more surface area, right?
Mm-hmm.
So this was your hypothesis. So we need to test if this hypothesis is true or not true. So we need to observe what is happening. So how do we know that the reaction reached a completion from what you can see now?
There's no more gas being formed?
Excellent. When the gas stopped form, it means that this reaction has reached completion. Okay, so now you are recording the time. Okay, Holly, what are you recording, or which one did you record for the?
Well, I'm recording the crushed one.
Okay, what was the time taken?
We're at 1:04. Is there still gas, or is it done?
No, the crushed done.
It's done? Okay.
Yes. And this one is still forming gas. So, any time?
120.
120 for the tablet. And Holly, what was for the crushed?
110.
110. Okay, so does this confirm your hypothesis?
Mm-hmm.
Yes. Okay. So what is your final conclusion for this experiment? Final conclusion. So as you said earlier, as you increase the surface area, the rate of reaction will increase. So today we said that we have different conditions to increase the rate of reaction. We just focused today on surface area, and later we will focus on different conditions. Okay, what you will be doing for next time? Can you think of a real application of the effect of surface area on the rate of chemical reaction? Real life application?
Chemicals have to be in solution to react? To increase
Yes.
surface area?
Yes. Can you think of anything that you can do at home to prove that surface area really, as you increase the surface area, the rate of reaction will increase? Can you think of anything in your kitchen?
Grinding coffee beans?
Yes. And what you add to coffee to make it sweet? Sugar. We have different forms of sugar, right? So we can have powder, we have crystal, we have like sugar blocks. So you can do this experiment at home when you take your permission from your parents to do so you can explore further the effective rate of reaction on, or the, to further explore the effect of surface area on the rate of reaction. Thank you.